Alright guys, welcome back to Underground Science. In this video we're going to be talking about nucleotide excision repair. Alright, so we've been talking about double-stranded repair for DNA. Now we're going to be talking about single-stranded repair. Alright, one of them being nucleotide excision repair. Alright, again, this is a single-stranded repair mechanism. Okay, so let's go and get started. So nucleotide excision repair, right? So basically, just looking at the name, what we're going to do is we're going to take out damaged DNA, right, that we need to repair, and then we'll repair it. That's basically what it is. So what we're doing here in nucleotide excision repair is we're fixing helix distorting lesions. Okay, so what's an example of that? Pyrimidine dimers. Okay, that's a classic example of helix distorting lesions. So what happens is when UV radiation is basically put, or if what I should be saying is when your DNA undergoes or receives UV radiation, you have the possibility of forming pyrimidine dimers. Well, thymine is one of the pyrimidines, right? So let's take thymine, for example. Let's say we have a double-stranded DNA, right? And we get some UV radiation, boom, right here, right? And then what does that lead to? Thymine dimers, right? Which is a type of pyrimidine dimer. Okay, well, what happens now? So now we have to fix this. So this is a helix distorting lesion, okay? It distorts the double helix. So what we can do is we can use nucleotide excision repair. So what happens is we have certain endonucleases that come to the site, right? Bind right near the thymine dimer, right, or the pyrimidine dimers. Then we take that out, whatever the dimer was, whatever the distorting lesion was, we just take that out with the help of endonucleases, right? Then that's gone. But then now we need the correct nucleotides. We need two normal thymines, not dimers, right? So then DNA polymerase will come in, put those two thymine bases in, right? Or the whole nucleotide, I should say, thymine, phosphate, and the sugar backbone, the sugar phosphate backbone along with the thymine, right? The correct nucleotides. But then look at this, right? Look, see these spaces, right? DNA polymerase doesn't take care of that. We need DNA ligase. DNA ligase will come in and seal the nucleotides together, right? Then you'll have a perfect new normal non-damaged no thymine dimers, right? No helix distorting lesions, and everything will be good. So that's nucleotide excision repair, right? Main thing to know though is that this nucleotide excision repair mostly occurs in the G1 phase, and that makes sense because you want to fix any of these helix distorting lesions before you go to the S phase where you're going to replicate your DNA. Okay, so you want to fix this before you replicate your DNA. That's why this mostly happens in the G1 phase of the cell cycle. Okay, so in short, UV radiation can cause a thymine dimer, it's a helix distorting lesion. Endonucleases can come in and cut that out. DNA polymerase will come in, put the correct nucleotides in, right? And then DNA ligase will come in and seal the phosphodiester backbone. Alright, that's basically it. That's nucleotide excision repair. And in the next video, we're going to be talking about certain diseases linked to nucleotide excision repair like xeroderma pigmentosum. Alright, hope you guys learned something and see you in my next video. Thanks for watching.